Hello everybody, this is Todd Frazee again, and this is the S60 129 cam tutorial for the crank. Now it's debatable on whether to make this part turned or you could make it complete on a mill. For the purpose of this class, we're going to go ahead and do it as a turn part with second ops on the mill. But because it's a rotational part, the concentric features would come out better surface finish. But you could feasibly cut this on a mill pretty much in one operation. But it'd have to come out of plate stock instead of round bar. Okay, so let's go to our Solidworks file. And it should look something like this. And this large diameter is 98 thousandths, so we'll probably take this out of 1-inch bar. And we're going to create a job. And we're going to do lathe turning. And it's going to be the S60-129 op 1 for the lathe. And we're going to use a cylindrical stock. Yeah, it looks like it's picked a pretty good facsimile. We're going to take, and our offset's going to be 1 inch minus 0.98 divided by 2. There's 10 thousandths per side. Might cut it out of bigger material, maybe 1 1/8, but it depends on the cost of the material. Okay, stock in the chuck, we're going to go ahead and put 1.6 is going to be in the chuck, and our backside offset is 2 inches, and then our front side offset we're going to put 0.02 this time, a little bit more. And so we actually want to change the X orientation. If we have it going in the long direction of the bar, we may be able to use the outside radius. So we want to change our stock orientation from front plane to Z-axis, and X-axis is going to follow the top plane. So it's going to flip X-axis in the same orientation as the big radiuses. 129.1, and our program comment S60-129 op 1 for the lathe. Okay, so we got job 1. We're going to type S60-129 op 1 lathe. First, select turning. We're going to do a turning face. We're going to go to the library, and we're going to use our cutoff tool. And this tool 1, it's a cutoff blade, but it is designed to also do regular turning as well. We're going to go 20 inches a minute on this. Go to geometry. We're just going to leave that as it is. We're going to go to our diameters. We're going to leave this all at default, except for we're going to go 0.01 deeper so that we're going past 0. And we're going to do wear compensation. And on the last tab, we're not going to have the lead in and out the same. 90, and the lead out's going to be at 0. Okay, so we're feeding straight in and then lead out away from the part. Okay, next we're going to do a single groove with that same tool. So we're going to go to turning single groove. In geometry, we're going to turn a single groove. There's our diameter. We're going to go to the front of the cutter and it's going to turn down 8 thousandths tall radius here. So we're going for from stock IOD cut down to selection, which is there. Okay, the next tab, leave that at default. Next tab, leave it at default. Okay, so our same blades coming in really slow. It's going to leave a substantial fillet here. So we're going to do one more. We're going to duplicate that, and we're going to make a different selection. We're going to edit, and on geometry, okay, we're selecting the larger diameter, and this part is tiny. Our cutting blade is actually wider than this, so that it's going to come in and do a pretty nice grooving on that. And again, we're offsetting to the front, going to the tip. From selection, we're going to the face I just selected, and we're starting at the stock outside diameter. Alright, so we've now got our orange profile that's showing the cross section. So it's going to leave a fillet here, but that's fine. All we have to do is turn the exterior and drill the holes. Yeah, the next thing we're going to do is we're going to drill the hole in the center. So we're going to go to drilling. We're going to use a drill, and we're going to use a spot face or spot drill from the lathe tools. Slow that down to 20 inches a minute. And we're going to select the one hole. We're going to go to the next tab, and we're going to keep all the defaults except for we're going from model top because we've already turned it down. And then the cut's going to go from hole top, and again, it's because of the spot face we're going to manually put in the depth. So we're going from hole top to a negative number here. So the major diameter of a 632 screw is 138 thousandths. So if we go negative 138 plus 0.01 divided by 2, that gives us our depth. Okay, so we'll get a pretty good size chamfer that will be a lead-in for the thread. Okay, and we're going to drill in and out. Okay, so there's our spot drill hole. Now we're going to go in with the tap drill. So we're going to go drilling, drill, and we're going to go to our library, and we're going to select from the lathe tool library, which is the number 36 drill, which we have in slot number 9. Okay, we're going to keep its default settings. We're going to drill the hole we have here, and we're going to go from model top, and the hole is going to go from hole top to hole bottom. We're going to bust through with the tip. The first 3 or 4 teeth on a tap don't do any cutting, so we need to go farther than that. So we're going to go a 632 thread. It's a 32nd per thread. So we're going to go 5 32nds and deeper with our drill bit. Okay, so we're going almost all the way through there. Alright, so we're going to go to the next tab, and this is going to be a deep drilling cycle, and we're going to go half the diameter, which is 0.107 divided by 2. Okay, so we're doing 53 thousandths pecs, and we're going to accept that. Alright, now we're going to come back in with the tap. So we're going to, learning from prior mistakes, we're going to label this spot drill. And this is going to be the tap drill. And now we're going to come in with our tap itself. So I'm going to go to drilling, drill. We're going to select from our library, from the lathe tools, our tap. Okay, I had that tap modeled the wrong diameter. It doesn't affect the actual thread, but I fixed the library there, and it looks like a better diameter. I'm going to go 500 RPM. It's a little fast. I don't like going fast with taps. And we're cutting this hole here, and we're going to go to the heights tab, and we're going to go from model top and whole top to whole bottom, but we want to go 3 divided by 32, 3/32 deeper, and that way we make sure our tap goes all the way through. And on the last tab, and so we're going to actually select right hand tapping to make sure it goes right handed on a lathe, and there we go. Alright, so we've got our threaded hole through the center, and now all we have left is to turn the exterior. Okay, so we're going to go to turning, and we're going to do a turning profile. And from our library, we're going to select tool number 3, which is our primary external turning tool. And we're going to leave the first tab at default. We're going to go to geometry. Confinement, I'm going to select the front edge. The back, we're going to go 180. Contain it between the two edges I just selected. We're going to go 180 thousandths pass. We're going to leave these others at default. Next step, not allowing grooving. We're going to select make sharp corners. Next tab. Okay, so we have a containment between the two edges. We lead in a straight line, come across. There's no roughing cuts because we're removing so little material, and then it's going to fade out. Okay, so our last lathe operation is going to be to part the material off from behind. So we're going to go to turning, and we're going to do turning part, and we're going to use tool 1 again. We're going to slow it down at 20 inches a minute. We don't need any confinement. Okay, and our heights, we're going to go to model ID, I'm sorry, model OD, model OD, and we're going to go to model ID, and we don't need to go any deeper than that because we have a hole drilled through. It'll part it off as soon as it hits that full drill bit depth. Okay, so we got our next step. Leave all that at default, and that at default. Okay, so we've got our cutting. So since this is a little bit new, we are going to go ahead and display what we're doing. So we'll do a stock simulation so you can see what's going on. Okay, so our parting tool comes in, faces the front, then it's going to come back, it's doing the next diameter. It steps in a little bit more, does the next diameter. And we have our spot drill, and we have our tap drill coming in. Now the tack comes in, pulls out. We've got our outside profile, and then we part our part off. Okay, so we have this disc shape, and we still need to come back and do secondary ops to drill the one hole and profile the exterior. Okay, so now let's do our next setup. We're going to go to jobs. I'm going to create a new job, and this one's going to be milling, and it's going to be the S60-129 op 2 for the mill. And we're going to go with a cylindrical stock because our puck is still cylindrical. For posterity, I'm going to go ahead and circle that. Our front side stock offset should be 0, back side should be 0. We're continuing from the previous job. Our stock orientation is actually fine the way it is. I typically put my origin on the bottom of the part, but it's okay. As long as you're able to clamp this thing somehow. We could use the boss for location. So that might be a reason to actually do the milling from this opposite side. The part doesn't have a clocking until we cut the outside and put these holes in it. And we're going to call this program number 129.1, I'm sorry, 2. And it's going to be the S60-129 op 2 for the mill. I'll accept that job. Let's change the name. S60-129 op 2 for the mill. So we're going to go to 2-axis milling, and we're going to do a 2D contour. And we're going to select from the mill tools, we're going to select the 3/8 flat end mill. Okay, we're going to say we're going to leave all the speeds and feeds where they're at. We're going to go to geometry, and what we're going to cut is this edge, but we're not going to propagate along Z, and we're going to cut this edge. Okay, and we're going to do a tangential extension of 0.2, which is a little more than half the diameter of the cutter, 200 thousandths. And on our heights, we're going from stock top, that's fine, but our actual cut is going to be going from selection, which is the top of this plate. Now, our stock was modeled as a disc. It's really only a disc from here down, so there's nothing to run into there. And we're going to cut down to the contour. We're going to the next tab. We're going to go wear, and 20 inches a minute. And we're going to do roughing passes. We'll do one roughing pass. That is way too much. So we're going to go do half of the diameter. So 3 divided by 16 would be half its diameter. And our finished pass is going to be 0.01. So 10 thousandths. Okay, we're going to go multiple depths. We don't need a finished pass in Z, but we do need a finished pass. We're going to go 30 seconds is our step. We're going to finish only at final depth. We're going to use even step downs. We don't need smoothing. We don't need stock to leave. We go to the next step. We're going to force the tool to pick up since this is such a small part. And we don't need a lead-in radius, but I am going to increase the linear lead-in to 0.125. And lead out will be the same as lead in. And I actually want the lead in to be at 0. Okay, so that cut the outside. Now the only other operation we have is to drill the hole. We're going to go drill. We're selecting from the mill library the tool number 7, the number 54 drill. We go to geometry, we're selecting our hole. We're going to go to depths, we're going to leave everything at default. We are going to go to the whole bottom and we are going to break through. And we're going to go negative 40 thousandths. And that's so that our reamer can go all the way through with its chamfer. Sorry, that can't be a negative number in that box. And we're going to do a deep drilling. And our peck depth is going to be half our diameter, so 0.055 divided by 2. Alright. Accept. So there's our deep drilling. Now we're going to go in with a reamer. And it's tool number 9. Same hole. Depths are all going to be the same, except we're going to go negative 0.03. So we're going to go negative 30 to make sure the reamer goes all the way through. And accept. Okay, that's it. And you should be pretty familiar with how that's going to simulate. So you got to upload 2 programs and 2 setup sheets for this. Okay, I'll catch you on the next one.